Next up, we have Tanya Sadhani, who will be talking about how adversarial noise protects my selfies from the AI-based deepfake TikTok dance trend. So let's welcome her to the stage.
Hi everyone, so welcome to my talk on adversarial noise and deepfake technology. So let's get started. My name is Tanya. I am an AI security researcher at Maleva Security Labs, and my background was in computer science. I'm currently still researching at the ANU, looking at AI safety, but before becoming an AI security researcher, I worked in governments in several roles, in technical roles as a data scientist and in strategic roles in policy teams. But that brings me here today with you guys to talk about deepfake technologies. Before I get started, I just kind of want you guys to have a look at the screens. So one of these images is not like the others, and for those who can spot the difference, come to me after the talk and I've got some coins. But by the end of this talk, you guys will know what I mean by one of these things is not like the others, and what this has to do with AI security and defending against the misuse of deepfake technologies. So on today's agenda, I hope to go through the problem, so share some trends we're seeing in deepfake misuse, the idea, so what is AI security and why is it relevant to defending against deepfake misuse, and an application of this, so using adversarial noise to prevent against non-consensual deepfakes, and then ending on a fun example, applying these ideas onto the TikTok dance filter. So, what really got me motivated to start this project was all the news we've been seeing about non-consensual deepfake misuse. As you can see on the right, we have an example of those kind of tools that can be used for this misuse. The screenshot on the left, I guess, from your perspective, takes an image of a person and undress them. And in a recent New Zealand report, they found a Telegram chat where over 600 women had their photos unknowingly used for this purpose. And that's what got me really worried. And we're seeing more and more of this misuse happen as AI gets more accessible. So My Image, My Choice is an advocacy body that is trying to find solutions against non-consensual deepfake misuse. And they track over 600 apps and services who provide this non-consensual misuse service on the clear web. And they found that 80% of these tools were developed and made in the last 12 months. And the trends are showing that this is not slowing down. Actually, can I get a show of hands? Who would consider themselves a machine learning or a data science person in this room? Yeah? Okay, so for those people, you might know what Hugging Face is, but for everyone else, Hugging Face is a pretty common space where data scientists put their models and host their models. And what I found really shocking is the wrong word, but sad, I guess, was that models on there were advertising the fact that they can be used for not safe for work purposes. When I first heard the news about, people being victims of image-based sexual abuse, I thought, you'd have to go to some seedy place in the internet to get someone to do that for you. But no, it's just kind of out there, really easy to use. So what are we doing to address this misuse? We've got people working on developing watermarking techniques, on detection techniques. There's a lot of interesting and good policy legislation and educational solutions. And these are important for remedying the solution, but don't necessarily do anything for preventing the creation of non-consensual deepfakes. Which is why I really wanted to focus on this kind of solution, the protective shield, or what we'll call today the adversarial noise, where you add some sort of filter onto your photos so that machine-based image processing things can't process them as intended. I really was motivated to work towards a tool or solution that gives the user more autonomy over their data so that they can post and interact in the web without fear of their images being misused. So that's what we're going to be talking about today. But instead of, to make this a fun talk for you guys to enjoy it, we'll be applying it on the TikTok dance filter. So does anyone like kind of know what I'm talking about? No? Well, let me play a snippet and talk you through what it is. Oh, I can't play a snippet. Anyway, so the TikTok dance filter is a trend that happened about a year ago, and it lets you take one image and make the person in that image dance to a TikTok sound of your choice, and it's really fun. Actually, no, this is where I can play it. It's really fun, and it's been used in many places, but for the sake of this talk, our goal is to be able to post photos, but make it so that my friends can't use those photos to make me dance to Jojo Siwa's Karma song. So yeah, that's the goal for today. And we'll start with a quick overview of what AI security is and why it's relevant to this idea and topic. So AI security is the practice of securing our AI systems from threats. AI systems are special because we have to consider all the standard cybersecurity threats they're vulnerable to, as any software system is. But in addition to that, they're vulnerable to AI-specific threats that take advantage of unique weaknesses that AI components have. In general, these AI-specific threats can induce kind of three failure modes. It can disrupt the system, so make it stop working. It can deceive the AI component, so you can make it act or predict in the way you want it to, and then you can get it to disclose or leak private information. The key idea, that was a really brief overview, but the key idea I want to share with you guys today is that adding AI to a system increases its exposure to other types of attacks. This might be really intuitive. Adding anything to any component to a system increases its attack surface. But I think this is something in my experience, that both data scientists and cybersecurity professionals tend to underestimate. And this is for two reasons. One, it's super easy to overlook all the extra dependencies that AI systems have. And all of these different dependencies can be manipulated and changed to influence the system and get outcomes you want. When you're dealing with a model API or maybe the model packaged up, it's easy to forget that it relies on a lot of open source software, maybe pre-trained model weights, a lot of data. All of these usually taken publicly because they're so big, which makes it kind of prime ground for it to be manipulated for malicious purposes. And the second thing, there's a bit of an informational gap around the risks posed by these AI-specific weaknesses. And this is not necessarily even on a person level, even though more and more people are being aware of AI security, which I'm happy to hear, but on a system level and an organizational level. So I don't know if anyone's heard of the Microsoft's Taybot, but there was an incident where people were able to influence the model to say not great stuff. And I think this is just kind of an example of these systems not being able to catch the risks and additional vulnerabilities of AI systems. The processes we have currently today don't account for them. I'm talking to you guys about deepfakes today, but that's kind of what I do on a day-to-day. That's my job, is to kind of look at the examples of models failing in the wild and see if we can learn anything from them and help organizations prepare themselves and adjust their processes to account for these AI risks. So these are other examples of attacks against AI systems. And I think for the keen-eyed people out there, I've chosen the examples that kind of fall under the three failure modes we talked about before. So we have an example of disruption, we have an example of deception, and we have an example of disclosure. So today, though, we're going to be using the ideas behind these different kind of attacks and incidents to defend against non-consensual deepfake misuse. So these are like generally the 5 steps of any deepfake technology. I've highlighted in blue the elements that have machine learning in them, which makes them like ideal targets for like an AI security attack. Where there's a lot of variation for deepfake technologies is this kind of third face merging section. There are very different approaches to it, all with its pros and cons. But today we're going to be focusing on a specific model, and this is InSwapper 128. The reason why we're focusing on this model is because it is so easy to use and find. When I googled like deepfake on GitHub, like the second most popular app has this in its like backend, and the screenshots I have are like other tools that use this model in the back. The reason why it's super easy to use and find is just because it's so convenient. It performs out of the box without any further training. It only requires one image to create like video and image deepfakes. So you only have to have one photo of your like target. It's really quick and easy, cheap to use, computationally so. I was able to like run this locally within 5 minutes of like setting it up, and it produces really high quality results. So because of its ubiquitousness, this is why I'm focusing on this model today. As fun side law, this model was taken down because of ethical concerns. So we don't actually have an original source for this model. Instead, there's just like copies flying around. All the different hashes and no clear information on versioning, which has some people worried about. This is another potential concern with downloading machine learning artifacts from the internet. But something I just found super interesting. There's not much information about it. There's no official source for it, and there's no way to further train it because the original developers have taken that all down. But for those who are interested, from inspecting the model, it seems to be some sort of variation of a style GAN, if that means anything to anyone in the crowd. So, my project aim is to use this adversarial noise idea to defend our photos against deepfake technology. So what is adversarial noise? Adversarial noise is a pretty well-established AI security technique that can disrupt and deceive models. So it takes kind of the input to your machine learning model. You make small intentional choices to try and get the outcome you want. You can kind of view it kind of as a search problem. You're searching for the changes you need to make to your input to get the output you want. It's been used in many other domains. I would say this is one of the original offensive AI security techniques back in the day, and it's been used against facial recognition, object detection. It's been used in the audio domain for sound-related things. But today we're going to be repurposing something that's traditionally been an AI security attack into a defense against non-consensual generative AI. So my project kind of started with an overview of the tools that exist, but I quickly found that there is no existing tool that is fit for purpose for defending against InSwapper, because all these tools aren't quite right. They all have a bit of a different use case. For example, one's used to kind of disrupt models that go from text to image. Another tool is used to help artists defend their images against copy, being copied by models. So not quite right. They all have kind of varying requirements for the method. Some require you have the model and be able to run it locally, which is not really the use case we're looking at today either. All of them target a specific version or type of AI, and they haven't tested it to see if it transfers to other types or versions of AI. But even though my hypothesis was none of them were fit for purpose, I thought it's super important to kind of benchmark and see how good these tools are out of the box. So these are the tools we're looking at today. These photos have had noise added to them. I'll show you, this is the images without the noise, and this is with the noise. They all approach it a bit differently. Forks and Loki were initially made to fool facial recognition. The idea being, if you post online and something scrapes your images online, they want to make it so that a CCTV footage of you can't be matched to your social media. On the other hand, we have PhotoGuard and Mist. So PhotoGuard and Mist, they are targeting those kind of big image generation models we're seeing today. They were made for artists, or to kind of prevent them from like having their works stolen. But I also just wanted to put a side note, just because these tools, I wanted to focus on the tools that were like aimed towards like a wide user, not necessarily like a data scientist, but because they're like out of the box doesn't make them user friendly. None of them actually worked out of the box. All of them had issues that I had to like fix, and that's not necessarily accessible for somebody who doesn't have the time to do that. One of the tools, Glaze, that people might have heard of, I was super excited to use it, but they actually don't had bugs, and they don't publish their source code, and they obfuscate the code, so we weren't able to test it. But I think this just shows again, these tools aren't necessarily accessible. But so let's go through the results. So I put in an original photo. I use a photo with just random noise as a benchmark. And I also put in the photos with noise added to them to our deepfake tool to see what outcome we'd get. And this is the outcome we got. So you can see a bit of like changes to the face, specifically for the ones for Loki and Forks. I think the reason behind that is because the tool itself was targeting a model that had a very similar style to InSwapper, whereas on the other hand, PhotoGuard and Mist were targeting kind of the big diffusion models that InSwapper wasn't. So the ways I measured disruption were, there were two ways. One, I measured the change in the pixels, and two, I wanted to use as a proxy a machine like face recognition model to see how different the faces were. And Forks and Loki really disrupted that facial recognition model because it was what it was designed to do in the first place. So I just found that as like a useful kind of result. But again, I think like visually, they did make changes to the face, but they weren't super effective as they could have been. I've seen examples of adversarial noise be more effective. And I think this is coming back to this idea of transferability. When these tools were made, they didn't really consider the importance, they didn't test for how they transferred to other models, AI systems. But I think that's the important thing here. We need to find an accessible way to develop and test different defenses against like not only just one, but various common deepfake models. So the project I'm working on right now is kind of trying to do that. The idea is that we then upload our photo, we add the defense we want to add, and then it runs it against the common models on that Hugging Face space that I told you guys about, just to see not only how does it perform against one of the models, but how does it perform against various models. I also just wanted to talk you guys through like the limitations of adversarial noise. So pretty big one is they can be circumvented by like relatively simple techniques. There are like complex techniques to remove adversarial noise, but some of these techniques are not, they're not robust enough that like when you compress them or when you rotate them, it kind of mitigates or removes the defenses we've added. And the second limitation is like another like coming from the difficultness to be like transferable. It often doesn't stand the test of time. As we're updating models, developing new models, old defenses might no longer work. However, I still think that adversarial noise could be a really useful like technique and tool here because it could address a specific problem we have, and that's this rise of unsophisticated and automated deepfake attacks. So like the bot that scraped social media to make like pictures of women, we've like seen demos of people making like automated phishing attacks. I think this is the specific problem adversarial noise would address. If anyone tries hard enough, they will be able to make like some sort of synthetic media of you. The question is like, can the people who don't put much effort into it do it? Yeah, that's coming back to like why adversarial noise, I guess. It's been proven in other domains, and we need a method that prevents the making of rather than remedying the solution after. Okay, cool. So we've gone through the project. Let's use what we've learnt there back on the TikTok dance filter. So what is the TikTok dance filter? So the organization behind it is called Vigil AI, and they're pretty cool. They've advertised this like new approach to creating deepfakes. And ultimately, I wanted to know if the previous adversarial noise methods designed for like the older deepfake technologies, would they work against this new technology that Vigil AI is proposing? So I reached out to Vigil, and they were cool with me kind of like trying out all the tools we saw before here. So how their system works is you take an image. This, again, actually, I should backtrack. Vigil AI is like proprietary, so I don't actually know what's happening. This is just based on what's publicly available and interviews of people talking about the tool. But you take like your video image input, you kind of craft like a human 3D skin, like for a human model, sorry. At the same time, you have your video input, you take the moving subject in it, make it into a 3D model, then you kind of smush it together, put the skin on the human, and create a deepfake video. So the systems behind this would be like this JST1 model, which is what they've been claiming is the new thing, the leading edge, but also like some sort of image-to-image model that we're probably more used to. And that's what our attack will be looking at, or our defense will be looking at today. The model will still be moving, but we're hopefully going to disrupt the process of translating an image into a 3D skin so that the thing moving won't look like us. To get around this, to understand a bit more about that like system or the like set of systems that exist in that second step, I kind of just like put in images to try and understand attributes of the system. So for example, I wanted to know if it would handle non-human subjects. I wanted to know if it crops faces, to what extent the background influences the output. How does it handle multiple faces? How does it prioritize faces? If I had I think another thing I would have liked to try would be how does it handle not safe for work things? Does it just block it? But I didn't want to get banned. So this is what we came up with. So based on the behaviors of the model, my prediction was that it's some sort of diffusion model. And MIST was one of the attacks that was aimed towards a diffusion model. So that's what we're going with today. And for the result, we kind of got this. I can't see if you tell, but there is a bit of noise on her face, but I wouldn't say it's particularly the disruptive effect we were aiming for. But yeah, so maybe it isn't a diffusion model is what I walked away with, but this is where we kind of got. No. Overall, it kind of shows the need, this need again, to be able to develop transferable defenses. Specifically towards the models that the bad actors are using most commonly. Cool. So wrapping up, today we talked about how the accessibility of generative AI technology is making non-consensual deepfake a serious and growing problem, specifically looking at these automated attacks that can happen at scale with very low effort. We looked at adversarial noise as being a promising technique to defend against non-consensual deepfake generation, but there's still work that needs to be done to make this a reality. And hopefully I've shared to you why I think there is a need to continue investing in protective defenses that transfer to various models. On the screen here, we have a AI-generated image of, I think, the Pentagon being attacked. It was, when it was posted to Twitter, it was quickly tagged as being AI-generated. But despite that, despite the detection, it moved the American markets. And I think this just really reminded me that detection and watermarking isn't enough. There needs to be some sort of protective measure, at least for our personal photos. We talked specifically about non-consensual deepfake misuse, but there are other ways deepfake technologies can be misused. So it's an interesting space to watch as we see solutions come up against them. And finally, ending on our AI security idea of the day, the idea that adding AI to a system increases its exposure to different attacks. Today, we use this idea to try and defend our photos against deepfake technologies, but with model owners, or if we owned AI systems hat on, this is an important idea to remember as we have measures to mitigate cyber security threats for AI security systems. But yeah, thanks for listening. I hope you guys enjoyed.